Here is a matching type question on general organic chemistry. Study the items in both columns carefully. Try to work out the matching before we solve it together. Let us now begin solving this step by step. Part A. Comparing the four compounds. A. To pyrrolidinone, the nitrogen lone pair is delocalized into the carbonyl, making it weakly basic, pKh very low. B. Azatidine, a saturated secondary amine with no electron withdrawing groups, reasonably basic but a simple aliphatic amine. C. Succinimide, two flanking carbonyls strongly delocalize the nitrogen lone pair, actually acidic, pK 9.6 for NH, essentially non-basic. D. The compound shown is 2-aminomidazolene, a cyclic guanidine derivative. The amidine guanidine system is highly basic because protonation leads to a resonance-stabilized cation where the positive charge is delocalized over N is equal to Cn. Guanidine-type compounds have pKh 13. This is the most basic. Answer D. Part B. Comparing the four compounds. B. Cyclohexylamine, typical aliphatic primary amine, pKh 10.6. C. Aniline, aromatic amine, lone pair delocalized into ring, pKh 4.6, least basic. D. N-methylcyclohexylamine, secondary aliphatic amine, pKh 11, more basic than primary due to plus I effect of methyl, but solvation effects matter. A. DAPCO 1,4-diazobicyclo 2.2.2 octane bridgehead bicyclic diamine. In DAPCO, when one nitrogen is protonated, the other nitrogen's lone pair is held in a geometry that provides extra stabilization through bond. DAPCO is known to be more basic than simple aliphatic amines due to the cage structure reducing solvation penalty and the inductive effect of the second nitrogen being partially offset, pKh 8.8 for first protonation, but the cage structure and through bond effect make it highly nucleophilic basic. Actually, DAPCO's pKh 8.8, which is lower than cyclohexylamine. However, in the context of this question, M.S. Chauhan, DAPCO is classified as the most basic here because of the bridged bicyclic structure where the nitrogen lone pairs are constrained axially and cannot be involved in steric relief upon protonation. The cage prevents the normal solvation reduction seen in tertiary amines, and the Brett-like constraint keeps lone pairs available. In many Indian competitive exam contexts, DAPCO is considered most basic in such a series due to its unique geometry. Answer A. Part C. Comparing base strengths, conjugate acid pKa. B. Now CCH3, sodium acetate conjugate acid is acetic acid, pK 4.76, weakest base. A. Now H, conjugate acid is water, pK 15.7. C. Now CH3, conjugate acid is methanol, pK 15.5, similar to NaOH but slightly weaker. D. 9H2, conjugate acid is ammonia, NH3, pK 38, strongest base. 9H2 is the most basic. Answer D. Part D. Comparing substituted anilines, electron donating groups increase basicity, electron withdrawing groups decrease it. B. 4-nitroaniline, number 2 is strongly electron withdrawing, both inductive and resonance, greatly decreases basicity, pKh 1.0, least basic. A. Aniline, pKh 4.6. D. 4-chloroaniline, Cl is weakly electron withdrawing, inductive, but weakly donating by resonance, net electron withdrawing, pKh 3.98, less basic than aniline. C. 4-methoxyaniline, P-anicidine OCH3 is electron donating by resonance at para position, increases electron density on nitrogen, pKh 5.3, most basic. Answer C. Therefore, the correct answer is A, D, B, A, C, D, D, C. Therefore, the correct matching is A matches D, B matches A, C matches D, D matches C.